Hi, this is Mrs. Kidman, and in this video, we're going to be reviewing how we shift graphs when we use function notation. So a reminder, when we're talking about function notation, what that means is I'm going to see this f of x or a g of x, that sort of notation thrown in there. And when we shift these graphs, the beautiful thing about shifting these graphs is that it's going to shift just like how our vertex form told us to shift or how an absolute value tells us to shift. It's going to look very similar. So when we're describing these shifts, really what we're looking at is depending on what's happening, we're going to see something. So if something is shifting to the left, what we're going to end up seeing is something like f of x plus some number, like plus a number, whatever that number is. So for an example, let's use a variable of g. So f of x plus g. That tells us that it shifts to the left. If it's going to shift to the right, then it's going to say f of x minus g. That's going to shift it to the right. Now, what about if we shift a function up? Well, to shift a function up, we are going to take our original function, f of x, and we want to shift it up. So I'm going to do a plus s. If I want to shift it down, it's going to be very similar. F of x minus s shifts down. Now, that's how we shift it, left and right, up and down. If we want to flip it upside down, what we're going to do is switch it. So we have a negative f of x. That flips it upside down. Keep it pointing up. Well, that'll just be a regular f of x. We want it to be positive. If we want to make it wider, then I'm going to put a c in front. I'm going to do some number times f of x under the condition that c is going to be less than 1 and bigger than 0. So it's going to be somewhere in there. It's going to be a fraction. Okay, and I want the absolute value of that. Then to make it skinnier, I'm still going to multiply some number times our function times some number, but that number needs to be bigger than 1. Okay, that'll make it skinnier. So using this idea, let's shift our graphs. So what happens when we have f of x minus 3? Well, that'll shift it. So we're going to shift to the right 3. When I have a minus 3, this will go down 3. When I have a plus 3, we are going to go to the left 3. If I have 3 times f of x, this is going to get skinnier 3 times skinnier. A negative f of x is going to do 2 things. It's going to flip over, so make it upside down, and it's going to, from whatever it was, flip it over, and this is going to get 3 times skinnier. Okay, it's going to do both of those. This one also is a combination of 2. This one is going to take it to the right 3, and it's going to take it up 4. So the biggest difference between this and something like the vertex form is these numbers in this case are shifting a whole function. When we have vertex form, we're talking about shifting x squared. But when we're looking at these ones, we're shifting a whole function. It doesn't matter what it is. So we're going to take that original function and shift it. So let's look at a couple of examples here. Now this first example is just our x squared. So when we're shifting our x squared here, here's our original function of x squared. It looks kind of like this. Beautiful, right? And then we want to shift it. So I want to take it 3 to the right. So we're going to the right 3 and down 2. That's what these numbers tell us. Notice how this looks a lot like vertex form, because that's what vertex form is. So we are shifting to the right 3 and down 2. So I'm going to go over 3, down 2, and then my graph is going to look exactly the same as it did before. I'm going to do this in a new color. So up 4. Okay, and notice how our graph looks exactly like it did before. We've just moved it, right? Same graph, shifted. We're going to do the same thing with all of these. So in this new case, we have a new function, and we need to graph this one. As I graph this one, I can see that it's going to have this point at 1. I need to find my vertex and my axis of symmetry. The reason why is because this is in standard form. So my axis of symmetry is going to be 4 over 2, which equals 2. So here's my axis of symmetry here. And then my vertex is going to be what happens when I substitute 2 in there. And that ends up getting me 4 minus 8 plus 1, which is -3. So our vertex here is going to be 2, -3. So here's my vertex point. And then I have that other point there. So graphing this function, if I went over to up to, I can go over to up to this one. And here's what our function looks like, right? Something like this. Now this f of -1 tells me that I'm going to shift this original function, this blue one, or this black one, to the right one. So all I'm going to do is I'm going to trace this function here. I'm going to take my original one, and now I'm going to move it, and I'm just going to move it to the right one. And boom, there's my new function. It just shifted directly over to the right one. That's all that this function notation does. So just like we saw here, it's going to shift it in those directions, just like our directions are giving us here. How we shift up, how we shift down, if we flip it upside down, if we keep it pointing up. That's all that our function notation is going to tell us. But instead of comparing it always to having an f of x equals x squared, now we're going to have any function that we want. So I can have anything. I can have this function in vertex form and I can shift it. I can have this function in standard form and I can shift it 4 different ways. I can flip it upside down. I can make it thinner. I can shift it to the right and up. All of those things. This function notation tells us how we can transform or shift these graphs based on our original one. So you graph your original one, and each of these things tell us how it moves, just like how in vertex form, when we graph x squared, those things tell us how it moves. And that is how we graph using function notation.